Okay. Hello, everyone. This video, I'm going to demonstrate the transverse shear calculation in beam. And this one I want to demonstrate is to calculate the first moment of area. Okay, because first moment of area, you have, I believe most of you haven't seen this the first moment calculation a lot, so I think you need more demonstration for the first moment calculation. And let's use the example 12.1 as an example. Okay, in previous video we already have the information of we already solved this problem. Okay, so in the previous video, okay, we solved the, okay, he give you, okay, the maximum shear stress. Okay, sorry, maybe I just need to. Okay, the maximum shear force. Okay, the maximum in the example 12.1. Okay, it give you the maximum shear force of the beam is 19.5 kilonewton, and then he want to calculate, okay, the shear stress at this position. Okay, this position here. Okay, and this position is the joint of these two, the joint of these two board. Okay, he said calculate the shear stress of this position. Okay, and the shear stress at this position, this can represent the maximum shear stress in the glue necessary to hold the board together along the seam where they are joined. Okay, and previously we already calculated the moment of inertia of this cross section area, and yeah, the value is here. And here I want to make one more comment of this. Okay, one more comment of this, the shear stress in beam. Okay, for the shear stress in beam, the maximum shear stress is at neutral axis. Okay, the maximum shear stress is always at the neutral axis. Okay, yeah, it's a maximum shear stress in this, maximum shear stress. Okay, not maximum shear force. Okay, so it's different. Okay, this the problem give you the maximum shear force of the beam. Okay, and then this led you to calculate the shear stress of this cross section. Okay, and the maximum shear stress is at the neutral axis. Okay, so in this video I'm going to talk about, okay, if the point of interest, okay, the point of interest, if we want to calculate the maximum shear stress, we need to calculate the Q, right? And the Q right now, the point of interest is at the neutral axis. Okay, and previously we say that if your point of interest is above above the neutral axis, you calculate the first moment above the point. Okay, and if your point of interest is below the neutral axis, calculate the first moment of area below the point. Okay, but when the point of interest is at the neutral axis, okay, at the neutral axis, and when the point of interest is at the neutral axis, we so shall we calculate the point? Shall we calculate the Q first moment area above the neutral axis or below the neutral axis? Yeah, that's a very interesting question. Okay, so the conclusion is if your point of interest is at the neutral axis, you calculate the Q above will be equal to the Q below. Okay, yeah, if your point of interest interest is at the neutral axis. Okay, so for example, we want to calculate the shear stress at the neutral axis. Our point of interest is at the neutral axis. So the Q above and Q below, okay, will have the same values. Okay, in this video, I'm just going to demonstrate it's really have the same value. Okay, so in the previous video, we already calculated the neutral axis of this cross section. The neutral axis is here and is 120 millimeter above the reference point. Okay, so our point of interest right now is here. So we have above. Okay, above is this shape. Okay, and below is this shape. And above, okay, let's see, above the neutral axis. Okay, so here is 150 and here is 120. So let's make a note on geometry information. So here is 30 and here is 30 and here is 150. Okay, this is a geometry information above the neutral axis. And also, okay, so I forgot this is 15. Okay, and okay, the below the neutral axis, okay, above the neutral axis we have a T shape, and below the neutral axis we have only the rectangular shape. Okay, below the neutral axis, what's the height? Okay, here is 120 and here is 15. Okay, here's 15. Okay, I want to demonstrate. Okay, the Q above and Q below is they have the same value. Okay, so first of all, let's calculate the Q above. Okay, Q above. Maybe I will use the new slide, empty slide. Okay, it's empty space. Okay, let's go create. Okay. Okay, so let's start with this calculation. Okay, so first of all, let's calculate Q above. Okay, and Q above. Okay, how to calculate Q above? Okay, Q above is a T shape. Okay, and this is a complicated shape, and so we have to divide it into a simple shape first. So we can divide in this way. Okay, divide. Okay, so we have two rectangular. Okay, we have two rectangular. We'll have two rectangular. Okay, let me draw this. We have two rectangular. Okay. Okay, so we have two areas. So okay, so our first moment of area is equal to summation summation I a I y I a I y I. Okay, so the pink one. Okay, we say the pink one. Let's say the pink one. We make a label. Okay, so I call here is 1, and I call this blue is 2. Okay, so what's our A1? Okay, the pink area. Okay, the pink area is 30 millimeter times 150 millimeter. Okay, that's very easy. Okay, and what's the Y1? Okay, what's the Y1? Y1 is the centroid to the neutral axis. Okay, centroid to the neutral axis. Okay, so in the pink one, the centroid is here. So okay, so what's the distance between this centroid to the neutral axis? Okay, do you know, like, based on this geometry information, what's the distance between this point to the neutral axis? Okay, so you have to be careful. The y is the distance between the centroid to the neutral axis. Okay, okay, the right now centroid is here. Okay, and to the neutral axis. Okay, here is 30, and this is the centroid, so this must be 30 divided by 2. Okay, so y1 actually is 30 plus 30 divided by 2. And times 10 to the power minus 3, and yeah, it's millimeter. Okay, so so that's A1 Y1, and our A2 equal to A2 is for the blue area. Okay, blue area. Okay, the area is 15 times 10 to the power minus 3 times the 30 times 10 to the power minus 3. Okay, and what is our Y2? Okay, Y2 is the distance between the centroid to the neutral axis. So let's see, the blue area is here. Okay, so the blue area, the centroid is here. So here is 30, you cut in half is 15. Okay, so actually your Y2 is 30 divided by 2 times 10 to the power minus 3. Okay, so let me check. Is this correct? Let me check. 30. A1, Y1. Okay, 30. Oh. Oh, it's 30 or 50? Sorry, sorry, this geometry information is wrong. Sorry. It's 30. Yeah, it's 30. Sorry. This is 30. This is 30. Sorry, this is 30. Okay, this is 30. This is 30 here, 30 here, 30 here. Okay, so that will cause some problems. So this A1 is here is, oh, this is no problem. Okay, the problem is for A2. A2, it will become 30 times 30. Okay, sorry, 30 times 30 and yeah, okay, it's 30 times 30. Okay, let me check my notes. This is correct. Yeah, let me see. 30, 30. This is correct. Okay, the other is this is correct. And this is correct. 30 plus 30 divided by 2. Okay. Okay, so the Q above, okay, you can just put this number A1Y1 plus A2Y2. Just use your calculator. And okay, let's see. Okay, so it will be let's see. So let's see for the A1, it will be A was 4.5 times 10 to the power minus 3 is A1, and Y1 is 15 times 10 to the power minus 3, and plus I think the other is 9 times 10 to the power minus 4 times 15 times 10 to the power minus 3. Okay, it's 15. Oh, sorry, this is 45. Oh, okay, 4.5. Sorry, this is 45. Okay. Let me check. This is 4.5 and it's 45. This is 45 and this 15. Okay, so and you add them together, the value will be 2.16 times to 10 to the power minus 4 and the m cubic. Okay, that's a Q above. Okay, so that's a Q above. Okay, let's see. Okay, if we calculate Q below, okay, Q below, okay, Q below is much easier because it will be Q below is just a rectangular shape. Okay, on the rectangular shape, where is the centroid? Centroid is here, right? Okay, so we only have the one area, so just A1, Y1, AY. Okay, we don't have label. Maybe just use the AY. Okay, what's the area? Is 13 times 10 to the power minus 3 times the 120 10 to the power minus 3. Okay, because this distance is just the position of neutral axis in 120 millimeter. We already calculated neutral axis in the previous video, so we don't have I don't want to calculate again. So this is the area. Okay, on it and times the y. Times the y here is the neutral axis is here, and okay, so the y is the distance between the centroid and neutral axis, and here is 60. Okay, here is 60. So you times the 60, 10 times 10 to the power minus 3. Okay, and you just use your calculator, you will find it's very magic. Let me check my number. Okay, correct. Okay, you will see the final value is also 2.16 times to 10 to the power minus 4 m3. Okay, that's what I want to demonstrate here. If your point of interest, okay, for the calculation for the shear stress in beam, if your point of interest is at the neutral axis, you can calculate the Q. You can calculate the Q above the neutral axis or calculate the Q below the neutral axis. Okay, because at the neutral axis, above the neutral axis, the Q above the neutral axis and the Q below the neutral axis, they will be the same. Okay, they will be the same. Okay, so you can use things in another way. So if you really want to calculate Q at the neutral axis, okay, pick up this shape is much easier to do the calculation because the Q below is just a one rectangular shape, much easier to do calculation. If you pick the Q, calculate Q above, Yeah, you still get the same value, but the Q above is much difficult for the calculation because Q above you have T shape, okay, and then you have to divide the T shape into two rectangular, okay, and it gets make the calculation a little more difficult. Okay, so if we want to, so let's just so that's why for some problem when we try to calculate the q at the neutral axis, they will pick the easier one to calculate, okay, because at the neutral axis q above and below they will have the same value, okay, and you plug the q into your vq over it. Okay, if you put max, that's just we just say the maximum shear stress in beam is always at the neutral axis. So if you plug everything in there, okay, VQ over IT. Q is 2.16 times to the 10 to the power minus 4, and I we already calculate. Okay, and the T is 30 millimeter. Okay, 30 millimeter. T is the thickness of point of interest. Okay, the thickness is thickness O is 30 millimeter. It's based on the geometry information of the cross section. Okay, so after all, I think you will get an answer about 5.2. 5.2. Let me see. Yeah, 5.2 megapascal. Okay. And in the previous problem, we calculated the Q. I think is right here, right? I think that previously we calculated previously we calculated shear stress at this joint, and then the value I think is 4 point something. Okay, and you see, okay, at the neutral axis, the shear stress is 5 megapascal. It's greater than the position at the joint. Okay, yeah. Once again, I just want to say that the maximum shear stress is at the neutral axis. Okay, so the value must be greater than the shear stress at this joint. Okay, I think it's 4 point something, right? Yeah, 4.8 something, right? Or 4.8 something. Okay, but the maximum it's at maximum shear stress always at the neutral axis. Okay, okay. So this problem I want to demonstrate. Okay, if your point are interesting as a neutral axis, calculate Q above and calculate Q below, you have the same answer. Okay, that's why I want to demonstrate this. Okay, so this is a very short video. I hope you can let you get more understanding on the calculation of first moment of area. Okay, because first moment of area, yeah, sometimes yeah, it's not that straightforward. It's not that straightforward. Okay. Okay, it's the first moment of area Q is depend on the position of interest. Okay, if Q is a function of Y, remember Q is a function of Y. Okay, if your Y at a different position, the Q is different. Okay, so calculating the calculation on Q is sometimes very annoying. Okay, so I just start video here. See you in another video. Okay, bye bye, bye bye bye. Okay.